everybody. My name is Deepthi. I'm the lead data scientist at Gogo. Hear me okay? All right. All right. So prior to Gogo, I got my bachelor's in electronics and communications. Did some software development, moved to business analysis a little bit. Wanted to really use the power of data to enable organizations make bigger and better decisions. So I decided to get a master's in business analytics from Michigan State. I'm a proud Spartan, as you can see. And after that, I joined Gogo about 4 years ago. I also happened to be, I think, one of their first members to be in the data science team and had the opportunity to work on some of the amazing projects. So coming to the topic today, for a lot of us, being connected to the web all the time is like a prerequisite. And there's nothing different about wanting to be connected on the flight. And given that, a lot happens in order to switch on that Wi-Fi enabled light on the flight. So I want to show you a small clipping of the behind-the-scenes preparation of what it takes to enable Wi-Fi on the aircraft. This was a video of all the behind-the-scenes work that happens to install Wi-Fi on an aircraft using our latest satellite technology called 2KU. To give you a little bit of this is just agenda of what I'm going to go through, but this is all our clients that have Gogo equipped on their airlines to provide in-flight Wi-Fi for their flights. This is basically an overview of how our technology works. There are primarily two kinds of systems. One is the air-to-ground system, where the airplane is constantly trying to establish communication with the ground, with the teleports on the ground. That's this part. So there is teleport here, and then this aircraft is trying to communicate this. The second type of system is our satellite technology, where we have our antennas pointing on the top, and then and they are directly communicating to the satellite and not to the ground anymore. So this is the basic difference between our air-to-ground and our satellite technologies. So today, I'm going to talk about a use case of what does it take to be connected on the flight, and what can be pain points or points of friction that can kind of hinder users from being connected on the aircraft, right? So just like our home network, in order to have your device to be connected to the internet, you first need your device to be associated with the wireless access point, which is the association piece, and then you need to get the IP assigned. And then if there is captive piece enabled, captive is the pages that you see when you go to Starbucks or in the hotels. Before trying to access the internet, they ask you for acceptance of terms and conditions and things like that. So that is captive. And then finally, you see the splash page, which is our Gogo page, where you have the opportunity to make the decision of whether or not you want to pay for buying internet, for buying internet, right? So this is a typical funnel, like you can see. And then what's the problem with it? Obviously, not all users who get to the association phase go to the splash page or end up buying our products. And there are two categories for it. One is people who just don't want to access internet on that given day at that given time. That's one category. And the other category is where users who want to access internet, but then there can be inherent glitches in the system that might be preventing them from progressing through these phases of the funnel, right? So today, I'm going to talk about the methodology or process that we adopted in order to identify these pain points for users who are trying to get to our splash page. And then why is this project important? Because it hurts our baseline. If people are not able to get to the portal page and not able to use our service, we lose out on our revenue. So that's the biggest motivation for this. I'm going to talk about the landscape of how we collected data, what kind of metrics did we build, how did we go about our initial data analysis, exploratory data analysis, and then how did we progress those ideas to scale it to the entire fleet of aircraft, which is about 3,500 aircraft that has Gogo-equipped equipment, right? Right. So for this project specifically, we call it frictionless 15 because it takes about 15 seconds for the user from the time their user device associates to the wireless access point till they see the splash page. And we want to make those 15 seconds as frictionless as possible so that the users have a good experience, right? So this is just landscape for data collection. So equipment on the aircraft, we install equipment on the aircraft to enable Wi-Fi. There is a CPU, there are different modems, and wireless access points, the same equipment that we use for our home networks, right? And those equipment send out logs to our ground servers, which is what we use to do all our analysis. And you can imagine there can be different types of logs that different systems on the aircraft send to the ground. So for this project, there are about 4 different types of logs. We established a focus group to kind of interview different departments in the company to identify what signatures can help us formulate a good user experience or a user's experience in general. So we collected all those signatures, We collected all those signatures and then created tables at different levels. One is at the flight level, how was the experience at the entire flight level, and then also at the individual user level, where if we know that an individual user didn't have a good experience, then we can go and analyze what happened with them. I know this topic of data quality came up earlier in here. We also built in inherent data quality metrics for all the tables that we have, wherein we count number of records, count number of unique aircraft and unique entities in our tables every day, and every time that deviates by a certain percentage, say 10%, we have alerting system to go and check what happened. So once we collected data, we built this KPI and metrics view for ourselves. And this view shows for each of the metrics in the funnel, say IP association, WAP association, IP, splash page, and for each of those phases, we created these views by airline and by different fleet types in order to see what kind of outliers stand out and where we can kind of start our analysis with. So obviously not all patterns are similar. You see some of them have, so this specific metric is IP assigned. So people here didn't get IP assigned, So it's different for different airlines, different fleets, different technologies, right? So we just wanted to see how that matters. And then once we did that, based off of just the IP assigned, this is one of the first observations we made. So in this graph, this is just time period. This is individual wireless access points. And each of these bars is IP to association ratio. So if 100 people were on the flight, and all of their devices got associated to the wireless access point, only 50% of the people got an IP assigned for those devices that got associated with these two WAPs. Clearly an outlier, right? And in our focus group, when we presented this case, and then when I say focus group, there's representation from engineering, airborne services, and then software teams who actually wrote the code for it. So when we went and told them this is what we see, they identified that for these two WAPs, which have these low ratios, the configuration, the WAP configuration for these two WAPs had some extra lines of code that were denying traffic for some of the users. And that's why you don't see all the users get IP here. But once we fixed the WAP config here, you can see the IP to association ratio just sprung up to 100%, just like all the other WAPs. And what does this do to our bottom line? So this graph here, this line is IP to association ratio, and this is number of sessions. This sessions meaning number of people who actually bought our service. So from an average of like 22 sessions for that one aircraft, we went up to like 25 sessions this is per day. So just by fixing one config and one aircraft, we were able to achieve this. This is the next observation that we made. So there's something called as a housekeeping process, right? At the end of each flight, there's a process that runs which will kind of release all the IPs that were held up in the previous flight session, so they are available for the new flight, for the users of the new flight, right? Now, if that housekeeping process gets interrupted, not all IPs are released, and then there can be problem of IP exhaustion, right? Because there are restricted number of, there are particular range of IPs that are allocated for that, right? So here, these are examples of cases where we saw those IP exhaustion, and then again, in the same focus group, when we presented that, we found that there was a polarity metric inside the EEPROM which was not set correctly, which was causing this IP exhaustion and interrupting the housekeeping events. And you can see once that got fixed, here, these are all the IP exhaustion events. Once that fixed, you no longer see those exhaustion events anymore. Third type of event, so I just talked about housekeeping getting interrupted, but there is another scenario of housekeeping never even getting started. And when that happens, same IP exhaustion problem, right? When we fixed that issue, housekeeping started to happen, and then everything works as expected. So these are some of the initial observations that we made from the dashboard that we built. And now the task was to, okay, now we have these observations. How do we scale this to our entire fleet of 3,500 aircrafts? And how do we detect if the same problems exist in the other aircraft? And if so, what do we do about it? And how do we do this on an everyday basis? So next, I'm going to talk about how did we deploy this to production, to the entire fleet, and what it took to do that. So here is our data engineering landscape. Like I said, equipment on the aircraft sends logs to our file server, which is on the ground. And as you can see, we moved to cloud, I think about 2 years ago. So all the logs that we receive, we store them in Amazon's S3 bucket, and then we run a Lambda to ingest. Our data engineering team does this, to ingest all those logs on an EMR cluster, and then the data engineering or the tables that I said we built for this activity, those are these features. So we build those features in order to create those tables. Now, after making those 3 examples, those 3 observations, we wanted to collect more metrics so that we can check if the same problem exists. So we built additional features, and then this is all in the cloud, happening every day, automated, and then just training of all the models that we build on top of it. All our machine learning models are right now offline. So this thing happens on in SpicePark separately. And then we store the results of the models in another S3 bucket. So not just for this problem, but again, for all the other problems too that we created models for, the framework is kind of the same. So we store the model output in table. Again, I'm just showing one model here, but then there are a number of models here. We use Amazon's API gateway to kind of interface with this table and read on a daily basis what's the status of those models. And we have an auto-ticketing tool, an internal tool that Gogo built, which will query these models, which will query the output tables for all these models every day. And it will go through the list of all 3,500 aircraft, and it will check if each of that aircraft has any of these problems. And if it does, it will create an automatic ServiceNow ticket if a ticket doesn't already exist for that aircraft on that given day. So this is our way of automatically monitoring if the problems that we discovered on a one-on basis, if they exist on the entire fleet, and if they do, how do we deal with it? Here is our process map of once we detect the issue, what do we do about it, right? So like I said, we have an auto-ticketing process. This is our auto-ticketing process. If there is an issue that gets detected, a ticket gets created, and that ticket gets assigned to our network operations center, whose job is to essentially see and validate whether that ticket is correct or not. Meaning, if we created a ticket saying resets were high, they validate whether resets are still high at the time they are resolving this ticket. And if they determine that the problem still exists, they're going to send it they're going to forward that maintenance request to our maintenance crew. And our maintenance people, who are most of the times at the airport, they have 2 options: either to replace the hardware if the hardware is broken, or to kind of troubleshoot on the tail to go and see what's happening. And they also oftentimes do remote fixes, which is if they just have to change a configuration, that can be done remotely too. And if they happen to remove the box, or if a hardware equipment gets replaced, that gets sent to our warehouse, where they actually test to see if the problem really existed, or to validate that the swap was indeed required. And if we are not able to kind of determine what the problem was, or if we can't reproduce the problem for which the hardware was removed, we usually send it to our vendors to do additional investigation. So this is our end-to-end process of how we detect problems right from data collection to those initial observations that we make, and how we take those initial observations and scale it to our entire aircraft, and then monitor for those problems every single day. And if those problems occur, we schedule maintenance activity right on that day. So through this process, I think the biggest lessons that I learned were people matter, their ideas really matter, and then also a lot of people coming from different backgrounds, different departments and different kind of exposures they have had, can have very different ideas. So it always helps to kind of listen to their ideas. I can vouch that without the help of that focus group that I've mentioned a couple times now, we as data people can only highlight what the data shows us in terms of problem areas that we see. But if there is not a focus group or a group that's actively generating hypotheses about what can be wrong and what needs to be tested, I think it becomes really difficult. We were fortunate to have that kind of support. Using data as an asset every step of the way. A lot of times, companies have people who go by intuitions. And again, they have been with the company for a long time. They know how the system works, and then they have intuitions based on what they have seen in the past. But then my recommendation would be to use data even to validate those intuitions too, because data is going to tell you, what actually happens. And buy-in from senior leadership, I know this was mentioned too. I think this is the most important of all. And once you have the blessing from your senior leadership, I think it just becomes so much more easier to carry on your entire data process. Otherwise, you're constantly trying to justify why you're spending that effort, right? And if there is one thing that I want you to take away from my presentation is to invest in a framework that will allow you to convert those little insights, those initial few observations that you make into actions sooner. A lot of times with data science team, the biggest challenge is the life cycle itself, how much time it takes for you to make those observations, build the models, and then prove that it actually works. I think we have found a lot of success in not tackling the full problem at once, but then tackling whatever pieces we could, and then just scaling it and monitoring it, and just tackling those pieces individually so that we are able to show value quickly, rather than just waiting at the end of the year to show like this one big project that we accomplished. With that, I will take any questions.
You mentioned the suite of models. Can you give some more information about
Sure. So most of our models that we built were for hardware components. So we're trying to predict when the hardware components failed. So some of the models are, we built, I personally worked on a Bayesian belief network that will predict when a modem that we use on the aircraft is going to fail, right? Some of the other models my teammates have worked are, I think, a GMM model, and then an anomaly detection model to see when certain parameters, say, there are two types of antennas that we have, transit and receive antennas. So when certain parameters of that antenna deviate from the normal range, So I think a colleague of mine developed an anomaly detection model to detect that fast change in the parameters of the antenna, which helps us predict when that antenna is going to fail. Yes?
How did you decide that AWS was the best platform for you to use?
So we didn't decide. I think this was a corporate decision that was made. We had the same problems. I know the other lady spoke about having problems about these different data lakes that existed, different silos that exist in the business, and then not having the ease of accessing data and not having single source of truth, which just doesn't help, because different people are talking about the same metric, but then are giving different numbers because they come from different sources. So I think this was a corporate decision that was made about 2-3 years ago, when we said, all right, we're going to shift everything to cloud. It gives the same advantage of, whenever you want resources, you spin up the resources as you need. When you need compute power, you have that too available. So just all the same all the same advantages that was spoke before. Yes?
Does the data collection happen at the individual user's device usage level also?
Yes.
So it's like not just, is it like in addition to the...
Yes. So we built different tables at different grains One is at flight level, one is at individual user level, to see if an individual user actually crossed all those stages of the funnel, and if not, like if everybody else in that flight had no problem, but just this individual user had that problem, then it's probably a device issue, or say a browser that's running on his device that might not support some of the services that we are providing. So those are the types of conclusions that device level information allows us to make. All right, any more questions? All right, with that, I thank you for the opportunity. Thanks so much.
Thank you.